Hi, it's Surds Maths Tutor, and we're going to be talking about surds. We're going to be talking about what a surd is, some of the basic ideas, and probably in this video we'll do the multiplication bit, and then we'll start talking about the addition. You'll need to know how to prime, factorise, all part of the toolkit stuff, all sort of the basics that you need to know. That is covered in another video, so if needs be, stop this one, go and have a look at that one, and then come back and restart here. We've also got to have some idea of what does surd mean. It's a crazy, silly word, but what does it actually mean? Well, it sort of means not a neat answer. Here's some examples. Here's a neat answer. What is the square root of 16? Nice and easy, it's 4. What is the square root of 4? That equals 2. What's 20 divided by 5? Well, that's nice and neat as well, that's 4. All of these things are nice, neat answers. Or what we could have is we could have something like what is a third? If we wrote it as a decimal, we have 0.333, and it goes on and on forever. In fact, you might even want to write it as 0.3 recurring, but nice, neat, round, easy to use numbers. But how about something like the square root of 2? Well, if you get your calculator out and work it out, it's 1.414213213 5, 6, 2, and it goes on and 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 on, never repeating itself. It's all pretty crazy. And you've heard the word absurd. Something's absurd, absolutely stupid and crazy and wild and doesn't make any sort of sense. Well, that's exactly the same as our friend up here, the surd. It's something that has got all sorts of chaos, doesn't quite make any sense. Square root of 2. That's nice and neat to look at, but when you start getting into the whole number of it and the meaning, it goes on and it's crazy. So surd just means it's difficult, chaotic, bit like a teenager, chaos, doesn't know where it's going. So because of that, surds are irrational. It's an irrational number. A surd is an irrational number. So here's an idea. Moving on to the next bit here. What's the square root of 4? Well, I've already put it up. It's 2. Okay, so that's one thing. How about 2 times 2? What does that equal? It equals 4, doesn't it? But we've just said that the square root of 4 equals 2. Okay, so what if I replaced these 2's with, what do you think? How about square root of 4? Because as we've said here, the square root of 2 equals 4. Okay, so the square root of 4 times the square root of 4 equals, well, it must be the same as this, equals 4. Now, from this, we gain an important insight into surds, and that is the square root of any number. 106. I don't know what the square root of 106 is, but the square root of 106 times the square root of 106 equals 106. The square root of any number times its square root of itself equals the number itself. And that leads us to a really important idea that the square root of any number times the square root of any number equals that number, and this is something that we will use all the way through surds. Now we've got that, there's also another rule, which is the square root of a times the square root of b equals the square root of ab. You can even write that the other way. Square root of ab equals the square root of a times the square root of b. What is all this crazy madness that he talks about? Well, this is what it means. If I've got something like the square root of 16, I can say that, well, 16 is actually 4 times 4, so the square root of 16 equals the square root of 4 times 4. which equals the square root of 4 times the square root of 4. Now we already know, don't we, that square root of 4 is 2 and square root of 4 is 2, and 2 times 2 equals 4, and in fact we already know that the square root of 16 equals 4, so it works. So I'm just going to pick a crazy example here of, I don't know, square root of 100. That could be the square root of 10 times the square root of 10. That would be your A and that would be your B, and A times B is 100. Or square root of, let's pick a number, 12 could be the square root of 6 times the square root of 2. This ability to manipulate things will come in handy. We could even say the square root of 2 times the square root of 8 equals the square root of 16, and here is where we see the power of it, because we know what the square root of 16 is, and that's 4. Bet you never thought that the square root of 2 times the square root of 8 was 4, but with this manipulation you can. Okay, so going into some examples now, and just to reiterate, a surd is not a recurring decimal, and is not a decimal that has some sort of end, like a quarter is 0.25. We'll also need to know how to be able to do prime factorization, and these two relationships will be key to what we're about to do. Okay, here we go. Okay, so let's have a look at root 8. So we'll go straight into our factorization bit, and you see I put 235 up. That's my reminder. I'm going to look at 2 first. Yep, 2 goes into 8 4 times. Still on my 2 bit. 2 goes into 4. Yep, times 2. So I've got a double prime at the bottom, which is here. That's where the double prime is. So what that means is that 8 equals 2 times 2 times 2. So therefore the square root of 8 equals square root of 2 times square root of 2 times square root of 2. Okay, so now what I'm going to do is I'm going to remember that the square root of A times the square root of A will equal A. I'll see that I've got 2 square root 2's here, so that must mean that square root of 2 times square root of 2 equals 2. I've still got a root 2 left, times root 2, and that is the answer. Square root of 8 equals 2 root 2. Okay, so let's do root 200 now, and I'm going to use the rule of root A times root B equals root A times B, and in fact the other way round you can write that. Root 8 times B equals the root of A times root B. So is there anything in here that I can do to pull that out? Well, I could say that root 200 equals root of 100 times root of 2, because 2 times 100 equals 200, and I've done it specifically like that because obviously you and I know that the square root of 100 is 100, and so therefore it is, the answer is on 10. What did I say then? Square root of 100 is 10, so therefore 10 times, bringing this down, root 2, so therefore the answer is 10 root 2. Another sort of important thing here is the fact that when we're looking at a root, if it's a prime number then it can't be taken any lower. It is what it is. It will remain as root 2. But this was a quick way. The other way that I could have done this would have been, in fact let me do it. Okay, so I'm going to go for the prime factorization method, remember it's 2, 3 and 5. So first thing we'll look at is the 2. Yep, and 2 goes into 200 100 times. Does 2 go into 100? Yes it does, giving me 50. Does 2 go into 50? Yes it does, giving me 25. Does 2 go into 25? No. Does 3 go into 25? No. I understand I'm doing this a bit fast, but just to illustrate the point. So I've got 5 and 5. So that means then that root 200 would equal root 2 times root 2 times root 2 times root 5 times root 5. And then I'm going to use this rule here, this rule at the top, and to do some combination. And I'm also going to use root a times root a equals a. So I've got root 2, which is 2, times, well, I've just got a single root 2 there, and then I've got root 5 times root 5, which is 5. So 2 times 5 is 10, times root 2 is root 2, which is exactly the answer we got. So the point here is that prime factorization, if you cannot see, quick multiples will get you out of trouble. So one more quick example, we'll do root of 50, and I'll go for the prime factorization method. 2, 3 and 5. Here's 50, 2's into 50, yep, they go 25. To 2's going to 25, no. 3's, no, but 5's do. 5 times 5, double prime at the bottom of the list there. So that means that the root of 50 equals root 2 times root 5 times root 5. Paired together, 2 root 5's, so that is 5, and then bringing in the final root 2 at the end. Okay, so now we're going to look at simplifying root 6 times root 3. And you begin to see just how important the general forms of surds are that I've put up in the right hand corner. Root a times root b equals root ab, and root a times root a equals a. Now there's ways of doing this. We're going to first though look at using this form, and we're going to, in fact we'll use that form and we'll use this form as well. So let's start having a look at how we can break this down. There's two ways of doing it. If I use this one first, that would mean that root 6 times root 3 equals, well, 3 times 6 is 18. I can then go through the prime factorization way of doing this. 18 is 2 and, in fact, let me write up 2, 3, 5. 2 and 9. Does 2 go into 9? No, it doesn't, which leaves me with 3 and 3. So therefore I've got root of 18 equals root 2 times root 3 times root 3. Pairing those two together, just like here, root a times root a equals a, and I've got root 18 equals 3, which comes from here, root 2. The other way I could have done it was to effectively, let me just clear this slightly, get rid of that, would have been to look at, also get my pen to work, root 6 times root 3 and use this rule straight away and looked at root 6. Now the reason I've chosen root 6 is because, as I may have said earlier, or did say earlier, root 3 is the root of a prime number, and because it's a root of a prime number I can't break it down any further. So that leads me to go for root 6 and try and break that down. And then I used the process of root a times root b. Well, what could that be? Well, it would be lovely if I could pull out somewhere a root 3, because then that would mean that that would combine with this one and give me 3. and that does work, because I've got root 2 times root 3 is root 6, times bringing this one down root 3, then pair these together, and I've got 3 root 2. Just as I did the other way. I stress again though that the important thing is if you can't see the multiplications in there, just go for the prime factorisation. Okay, so here's the next example, root 6 times root 12. So let's have a little look at this. And okay, well, we'll try looking firstly at breaking down the 6 and breaking down the 12. And I'm instantly looking at this and thinking, well, okay, I wonder if there's some root 3's in here. I think probably that would work, because root 6 becomes root 2 times root 3, and then if I look at root 12, there's still the times here, times, well, if I'm just going to prime factorise that, it would be 2, and it would be 2, and it would be 3. So I'm sort of mixing techniques here. As I say, there are many ways of doing this. And yeah, here we go. I've got my root 3 and root 3, and in fact I've got another pair of 2 root 2's. So let's just tidy that and bring it all together. So I've got root 3, which is 3, times root 2 times root 2, which is 2, and I've got left a root 2. 2 times 3 is 6, times root 2 is root 2. So that's what root 6 times root 12 is. Now, let's just say I can't see any of that. The exam is not going well. I'm under pressure for time. Can't see what's going on. Doesn't matter. Let's bring into play root A times root B equals root AB. Okay, well, I've got root 6 times root 12, so that's 6 times 12. 6 12s are 72, so root 72. And then what I'm going to do is I'm going to prime factorise 72. So there's 72 prime factorised out, so that means that root of 72 equals root 2 times root 2 times root 2, which is those 3 there, times root 3 times root 3, which is those 3 there. And now I start to sort that out, and I've got a pair of root 2's here, which is 2, times, well, I'll take the pair of root 3's here first, 3, and then I've got a root 2 left, which is that. So that is 2 times 3 is 6, root 2. So exactly the same answer, but just a slightly different way of doing it. Surds, it's whatever you feel comfortable with. Think about the pressure of the exam, time and what you've got to do. Fall back on what you know works. And I have to say prime factorisation is always going to work. Okay, that completes this tutorial looking at what surds are, some of the basic bits of toolkit you need for surds, and surd multiplication and breaking down that multiplication and prime factorisation to simplify. There will be another video which will be about subtraction and addition. There will also be within that about how to conjugate and also rationalising the denominator. This was Saltash Maths Tutor. Thank you.